Up into YouTube. I think that was it. Turn it off here. I don't know if anyone's online yet because I just shared the YouTube link. Previously, they said, hey, we can't hear you. I think we can hear you. I guess we'll find out if there's no audio on that. Maybe I'll have the marketing guy check on. Yeah, I tweeted it, linked it, put it in the meetup. Yeah, I talked about you. Only in the ring, man. You should put some sensors. Oh. Yeah, like when you're doing some MMA stuff, that'd be kind of cool. Real time. People might actually come out for that one. You don't even have to give away pizza. But I mean, that's why Slice is in there. That was Pino's marketing to put Slice in there.
No, it's all my responsibility.
You put Slice in there?
In the description.
No, this one in the title.
Yeah.
You were the Slice man?
Because I have a pizza shop example.
Oh, that's right. I forgot about that. Oh, then it's okay. 2 uses makes sense.
Also, I have generated title for my presentation using the journey, and it has a pizza there. So 3 out of 3.
Oh, well, then we didn't have a choice. Okay. What I was going to ask for marketing, the entire department in the corner.
Yeah, this is that.
To check YouTube, make sure the audio's coming through. Because I haven't seen anyone pop up complain yet.
Yeah.
We got audio? Okay. Okay, your job has been solved. You can go home. No, he's got to take home the pizzas. Unless people take them. So you're at the meetup. If you have ideas for future talks, things you want to see, do you want workshops? Do you want it different times a day, different times a week, different locations? You can definitely just reach out or tell us today. I also have, hello. Let me get to this link. I'll go back to these other ones. I have the Slack that I'm using for the demo is also the Slack for the meetup group. So if you want to interact, or maybe we'll do that with another event, put your suggestions in there. They will get sucked up in here and get pushed out through Gen AI, which is silly, but I'll have to figure out, maybe I'll set up another group for that, another channel for that in Slack, but just for now. Yeah, if there's different things you want to see, do you want to see a workshop, different time of day, different location, reach out. I don't know, this is optimal. Clearly with 4 presidents in town, it's raining and there's a big holiday coming up. Maybe this wasn't the optimal time to suggest it. I am very impressed. People are here. You are awesome people to come out. This is me. I run this meetup and the Princeton one and the Philly one. I prefer doing the Princeton one because I don't have to get on a train, but you tell me. We also have coming up a couple events in Princeton, one at the university, one outside. We're doing a big AI event with Startup Grind. But if you want to reach out to me, any of these places are good. Or again, that Slack channel is a good way to do that. Like I said, those are the 2 major ones. I try to federate the information between them. So if there's people virtual, you could always attend or see it later in YouTube. I do a weekly newsletter, covers a lot of stuff. You could subscribe or not subscribe. I keep a copy in GitHub, so you could just go there. You don't have to subscribe and get any kind of spam. Again, if you want to join the Slack, that is connected right to this demo. Obviously, when I turn off the demo, it's just going to be sitting in Slack, but it is live connected right now to it. So what I'm going to show you, my use case is not having to write code and being able to do things in a streaming manner against different models, different vector stores, a bunch of different use cases, the easy way, and that could be done fully open source, which is what I usually talk about. But I want to make sure people know if you're afraid to do these kind of things in production with pure open source, there are people who will support you with production level platforms. And I'll show you, we can pull in unstructured data, structured data, all different kinds of data, bring it in, stream it, send it to whatever model we need to send it to, and then have it processed very easily. And we're using all the stuff you expect to see, the closed models, the open models, most of the vector stores. I use Hugging Face in a lot of places. This is my new favorite place. Obviously, everyone knows Hugging Face, but there's a lot of good stuff there. A lot of great libraries, a lot of great models. I'm using a bunch of their models today. Just to show you what I'm doing, we're going to focus on the real-time data ingest and getting it to vector stores and models, getting it round-tripped, and then feeding it to other places, and show you how to do that within Flink SQL and within Apache NiFi with too many click-throughs. This is generally what we can do. Get whatever context we might need, and that could be from wherever it needs to be, hundreds of sources. Ingest this, all this codeless, clean it up, enrich it, transform it to the way it needs to be, including using whatever Python libraries you might need. And that could be binary data. I'll show you images, text, whatever it needs to be. Getting your prompts built and optimized, again, codeless. Getting whatever context out of, Pinecone, Chrome, or whatever, and have it round trip so you can even do this as your interface. So again, I'm using Slack as my input and Slack as my output. Makes it very easy. Obviously, I could push this to any other kind of front end you would want, but to do that with no code, pretty nice. The main project to do this is NiFi. It's been around for a while. One of the features that has proven very helpful when you're trying to build out these generative AI systems is to be able to know what's happening. Obviously, there is a lot of systems here. I could be calling Hugging Face, where am I in my application run? It can go through a lot of steps, a lot of different systems. NiFi has provenance, a data lineage of everything that happens, so I can easily track what's going on, see, oh, what did I do wrong? Oh, I forgot something. It should have been JSON, I sent text. Those kind of things, very helpful for tracking what's going on or keeping a permanent record of everything that happened. And to be able to work with whatever data you want. Again, all this for codeless. So if your data is in any of these formats, regardless of the schema, what it looks like, doesn't matter if it changes. I don't have to write any code. I don't have to pre-build and type in all the fields, and then someone change the name of a field and things start breaking. Don't have to worry about that. And with the same system, I could work with all kinds of unstructured data, whether it be TARD files, images, videos, any kind of weird document format, all kind of social chat, all those kind of formats, extract them in the format you need, usually text, put them in a vector store, use them just as a text in a context, or just store it somewhere, or send it to different types of models, whatever you need to do, and interact with most of the major services there. I forgot to add, I'm also working with Olama. So if you want to keep everything local, especially you're doing development, same thing. Lots of different places we can call, whether it's in the cloud or locally. Pretty easy. The most exciting thing is the new features we have in the new version of NiFi. This is running on the latest JDK, so performance is pretty amazing. And we've added full Python support, so I can drop in any little Python apps I need to do processing. And I'm writing these like, it's just like writing regular Python code. I drop it in a directory, and now it becomes scalable out to 1,000 servers and has all the lineage, provenance, management, and security and governance and all those things that you need in an enterprise app. I've got one example using Google's Gemma models. I've got some with using Pinecone or Chroma in it. The usual thing I do is grab the documents from wherever they are, S3 bucket on your file, parse them, chunk them up, get them in the vector store, maybe also store that in a different format somewhere else, maybe a database, maybe S3, maybe push chunks to Slack, or get appropriate sized formatted chunks in JSON into Kafka to share this with other platforms. That could automatically be injected into Pinot or somewhere else, wherever you want to go once you're in Kafka. The Python processors, I've got one to extract out company names. This is helpful because it's part of my flows. If someone asks me, what's the current stock price for Amazon? I'm not going to call an LLM for that. I'll parse out the company name for your question. I have a routine that will grab their stock symbol and then call another system to get their current stock price. Again, if there's another part of that question that should be enhanced with LLM, we could do that. Marketing in the back. Here's a stupid answer. I don't think so. Prompt, I don't know. It could be. I mean, to me, it's prompt. Yeah, it's LLM avoidance. So I just saved $72. For someone to ask a dumb question and get back not what they want, which is more important, but prompt. More of should I use an LLM question? Prompt routing. Yeah, you think of some good marketing term, or just type it into ChatGPT. It'll give you one. Call Watson. They have an SDK. This one I added, and I'll show you that in the demo. There was a good Salesforce model to add image captioning pretty quickly. So this one looks at your image, throws some captions in it. That's nice for me. I was thinking at the end of the meetup, if you take a picture, we could upload it in Slack, and this will pull it in, add a caption to it. I also got one that will find objects in there like, oh, look, people. Very, very exciting. But to do that automated, you just put it into Slack, all this happens. And this is the one that puts the nice little squares in there. Well, here's a person, a TV, whatever that small data set is. This one I figured is more important if I'm letting everyone upload images. I've found on Hugging Face a model that detects things I don't want being posted on the Slack group. Because this has happened in the past. You give people open access to something. Besides trying to Bitcoin mine, they might try to send inappropriate pictures. This will find it, and I put it to the side. And then I'm going to add to that workflow where you get banned. You shouldn't be doing that. I also have another one elsewhere that does that for text. Find your facial emotions. So I'll know, okay, don't do this topic. Everyone looked sad or tired or bored. We'll just avoid doing that topic. Flink SQL is pretty cool because I could do SQL on real-time data like Kafka, live sensors, whatever is real-time. And we can integrate with a model. So I tried this out, and I share this in the demo. While messages are coming through Kafka, I can send that against different models in different hosting environments and get back results and put that in my SQL. So I could do calls against an LLM through either directly through something like Cloudera Machine Learning, or I could have called Hugging Face directly, or Watson XAI, or OpenAI. Those require a little bit more processing. And I also added, in case I don't want to do anything, I have NiFi act as my interface to do the prompt engineering and cleanup and enrichment. So in case you send me junk, I don't just send that to the model. I'll parse it out before it goes there. And then also you can make decisions on, do I want to just grab it from a vector store, another database, or some cache, as opposed to calling the model again. Especially when I'm doing stuff in streaming, if I'm making millions of calls, I probably should be caching that or avoiding calling these models, even if they are local, as much as possible. Obviously, that's heavyweight. That's a lot of horsepower to do that. But really, this is how I call it. I send the text to that function. The function is defined previously and calls the model This one calls the Cloudera one. The other one calls the one that I'm hosting in NiFi. And what's nice when you do this, when I write these queries, they work on the data in real time as those events occur. But for people who are working with like something like a Jupyter notebook or a front end, you don't really deal with streaming data and you don't want to subscribe to a Kafka topic. So the Flink tool will produce a REST endpoint that produces JSON of the most current data in the system so that you can query it very easily with pandas or anything else. And then you could use it for your analytics. And obviously, if you're doing something like a Jupyter notebook, you're not expecting, instant events. Maybe you're looking at data from 2 minutes ago, 5 minutes ago, whatever's near enough for you. I mean, you can consume Kafka from a Jupyter notebook, but it's a little, yeah. And usually that doesn't make sense for a data scientist who doesn't want to do that. Maybe they even want to see an aggregate. Like that's the thing we could do with the Flink SQL is do aggregates. Maybe I just want to see how many people asked the same question, maybe how many tokens it took because I have that in the metadata, and just give aggregates. They go to data scientists, they could do all their science and analytics there and have fun there. And then maybe they could decide, what should the data do later? And we'll just push that further down the chain. We could push it up into NiFi or into Flink or into Kafka. This is how we create a table in Flink. And what's nice is the tool will infer a Flink table by just looking at a Kafka topic based on the fields in there, whether it's JSON or Avro. That's helpful so I don't have to manually type out these tables. Kafka, we got the Kafka guy here, so I'm not going to go into it, other than I got to take a picture at the Kafka Museum in Prague wearing my Kafka shirt. Kafka's cool. That is the way,
I have the same picture.
You got that picture?
Yeah, I'll find it.
Okay, we got to post that on that. Why is that not the Meetup title, man? That'd be cool. We have a tool to do replication, so Kafka's cool. I tend to use it as a way to get data to share it with someone because it's never just one person wants this data. Someone else wants it, and to be able to get it to them instantly, no matter how many different consumers, whether it's Pinot consuming it, NiFi, Spark, Flink, Python, Java, Rust, Scala. There's a ton of different tools out there. So once I get it into Kafka, everyone can get access to it. For us, we also like to stream that into Iceberg. So you've got an open data lake of, massive amount of data with some cool features like time travel and things that we really should have had 4 or 5 years ago in the big data space. But, what are you going to do? Iceberg is cool, and they generate pretty good things in Gen AI. I like those. They put some good stuff in there. And we've got a pre-built component that'll just stream your Kafka to Iceberg. We also have one that streams it right from like a Debezium source to Iceberg as CDC. If you don't know what Debezium is, it's for CDC, change data capture from databases. So you can have an Oracle database, stream it right into Iceberg, and get them in sync without having to write any code, which is kind of nice. And we've got a full data lake there with all kinds of security and stuff. And we could do that directly from Flink if we wanted, or we could do it from NiFi, whatever makes sense for you. But let's show code and not slides. All the slides are available. The one thing I wanted to mention is all the demo I'm doing is on these 2 Docker sets. One has Flink and Kafka. The other one has NiFi. And that's all I need to be able to do the demo and access to a model, whether that's Olama or Hugging Face. Those are external. Yeah. I mean, you're just downloading a Docker, compose file. It's not we're not giving away the $1 million there, but it works pretty well. And that's literally what we're doing for the demo. It's all running on my laptop now, other than services that are external like Slack, Hugging Face. Those are external. let's see the chance that everything in the world didn't time out while I'm doing that. I think everything in the world timed out. Let's see. Maybe not. Okay. So this is NiFi. I'm going to show you how we get this started. So I have a Slack group here that I sent you the invite to. Again, that's why I have those filters on there. So you can ask questions here. Maybe I'll set up another one if you want to set up ones you don't want generative AI answering. Like if you go, hey, can you move the meetups to Tuesday? You'll get an answer. I'm curious what it is. I'm not going to ask that question because I'm sure it's going to be nonsense. But one time I asked a question, what is the country that Tim Span founded? And it created Timistan, which was really cool. Then they removed that from their model. I was very upset. I had a country, then lost it, which is the worst. What about all our minutes of culture we lost? Okay, so we type in something into the Slack group, and setting up a Slack bot is super easy. So I have that documented in a article, but what happens here is I have a 9.5 flow that listens for Slack messages. This is a new API Slack added, and you make a call out and you get WebSockets. It's really nice. Gives you everything that happens in there that you've set up in your permissions. So I can get that message, and then I'm going to process everything out of there. Make sure it's not me doing it, not the results of the bot, because I've accidentally done that, then got stuck in a loop where, you know, LLM is calling LLM with the results of the previous LLM, and it just keeps adding to it. So I parse it out. Here I'm calling a Hugging Face model to make sure there's no New Jersey speak in the text there. And then we get through that, parse that out, and then again, the prompt engineering part. Then I query against my Pinecone database. I'm not running this locally. I have a free Pinecone account. Then I'm parsing out the text, getting the fields I want. Ooh, someone stopped that. The thing with NiFi is you never lose data. So I can start and stop any piece of a process real time, whether through the UI, through the command line, or through a REST endpoint, or through something like Terraform. So I stopped it. There's a configurable queue between every step. So we never lose data. And if there's a back pressure event occurs, it just stops it up the chain. It makes it nice. But if you forget and stop something like I just did, it's just that last call didn't go anywhere. Now, I have a lot of different models I could send this to in a lot of different places. Someone was dumb enough to lend me their Chat GPT account. So I can call there. I tend not to call that because, you know, you call them, it's $1 a call. Hugging Face is usually free, so I usually use that. I also sometimes run Olama on my machine. If you haven't seen Olama, you could run some serious models on a laptop pretty well. They're actually not bad. What I'm using now is my flavor of the week model that I like is Mixtral 8.7b, the Instruct one. This is using the new experts model, which is kind of cool mixture of experts. It sounds very advanced, so I like that. The results are pretty good. They're better than Google Gemma, not Gemini. Not as good as OpenAI Chat GPT-4, but still pretty good. So I call that model with that input from the Slack plus some context from Pinecone. I fed all of my slides and all of my articles into Pinecone as a local context for questions about this meetup group. So hopefully you ask a question, it should be better than the generic one because we've augmented it with a context from, you know, local content. And then it goes through all this nonsense, and then we send it back to Slack. what's nice is because we included the timestamp, it connects to your question. So it comes in a result here. Now I put a lot of metadata in there so I know which model I'm using, when I called it, who called it, how many tokens it took, how many characters, how long it took, just how to do it. This pulled this right from one of my presentations, Apache NiFi, most active communities, blah, blah, blah. So it'll do that. The other thing I have set up is one that deals with images. So I can grab an image. This is coming from Zoom. So if I look at here, there's a lag that's a little painful. So let me pick an image from one of the previous meetups or, oh no, I was in Brazil here. This was cool. So I'll upload a picture like at the end of this meetup. If my marketing guy's not taking a nap, he might have a couple of pictures. I might upload them. I'm always picking on him. He's a cool guy. So when it's done, it will send the results to a Slack channel, and it'll give me analytics of what's going on there. Plus, if I didn't shut that down, it'll send me the image as well. As we saw here with the previous one I uploaded, it did the analytics on the cat. Oh, I think I turned, let's see if we turn that off. But it's pretty straightforward to do all this. Again, my thought is to make the meetup more responsive. So if you have a question, obviously I'm watching my Slack group as well. So if it does a bad job, I'm trying to figure out how I should rank the answers. Like if you reply and say that didn't help, maybe I'll parse that or have a keyword and send that as a internal message to me to say, hey, this is the question. The LLM didn't do a good job answering it. Maybe you could do slightly better, and then get back to you in, you know, in human time and tell you the results there. Let's see. Me in my pajamas. I don't think I'm wearing pajamas. You saw this picture, right? Does this look like pajamas? I don't know. Not the best. Okay, it is a suit that has Pac-Man on it, though. Uh, I guess that's if it would have said Tim is wearing a suit with Pac-Man on it, then I know that's the top model. I keep trying new models. When I get a model that tells me what I'm wearing and says, "Oh, Tim bought this from this time from Amazon," then I'm like, "Ooh, we got to close down some data sources." But so far, it figured out who I was. So I mean, I guess that's okay. It's not the worst thing. Well, we'll see when I upload the rest for the next one. Do we have any questions before I switch over to our second talk? Make sure your Zoom works. We'll have him check that while we get through this last bit. Again, this is all being recorded, and it is being streamed on Zoom and streamed in YouTube. So there'll be multiple recordings. Maybe one of them is okay. And the slides are posted with all the code. So if you missed something, you came in late, it's all available to take a look at. Does anyone have a question or an idea like we mentioned before? Hey, can we move these to Tuesday? Can we do them during the day? Can we do them in Jersey? All those kind of things. If you say Brooklyn, I don't have anything in Brooklyn. If you got someplace really awesome in Brooklyn, we'll send marketing there. You'll like Brooklyn. Any questions besides who want? If you ask a question, you got to take a.
As long as the YouTube stream is
Yeah. Or I can have my. Oh.
And where's my clicker? We're gonna start in 1 minute.
I'm just gonna leave that on. I'm gonna leave mine on just to make sure it doesn't mess up any, Zoom stuff.
Probably.
There's someone sitting in front of it. I'll grab you one for the cooler, which is almost.
Right.
Almost. Very similar.
Thanks, Tim.
Couldn't be easy.
Okay. Hopefully, internets are listening, and hopefully you can check the YouTube stream. So my presentation would be not that exciting because there's no AI thing, but I think it's important in terms of getting data. That is also important. So since we're talking about pizza, and we need to mention pizza 3 times, right? So the first time the pizza was mentioned here. How much pizza we sold? That's the restaurant, the owner would, the question that the restaurant owner would be very much interested in. Or if you're running chain, you don't really care about like a particular slice of pizza. You care how much revenue you're bringing into the table, or like a particular branch is getting the selling pizza, and how many orders we're selling, and how busy is a restaurant. So those type of questions you need to get answer relatively in the real time, ideally, or like you're looking for the where to order your dinner. Maybe you travel and you're not in the mood to go in the restaurant. You want to order something from Uber Eats, for example, and you check in what's the average delivery time from the restaurant in the area in the last 30 minutes. So it sounds more or less real time-ish. So in this presentation, I would like to show you some of the tools that you as an application developer can use to develop systems that will try to answer these type of questions. Okay. So that's kind of like a premise. And yeah, there will be dashboards and there will be some advices in terms of how to build those dashboards. But dashboard is like insights we can get straight. So pizza number 2, it's the generated image about the pizza meetup and the real-time insights, and there's some how the Midjourney um, analytical stuff. So I say, okay, give me an image of pizza, slice of pizza in the real-time analytic world. I'm going to be talking about the lab database, analytical database called the Panel. It's an open source project that was, as many the modern open source project was developed in LinkedIn. How many of you know other open source projects that develop in LinkedIn? Maybe starts with K. Kafka. Okay. Yeah. Anything else? Any one? Some of the things around managing Kafka, cruise control, also. And Apache Pinot also was developed in LinkedIn. There's some projects that like Espresso and Voldemort, they were developed. They kind of sort of the people were talking about those that were not that popular, and they were not. I believe they are not open source. I'll show you because I build highly scalable and highly available Hello World applications. Most of the time they over-engineered, but what's the fun if you're not over-engineering your demo? So in this particular case, in this particular example, I'll show you full-blown stack of technology can be used to build real-time analytical applications. So, and some people who've been in the data world for a while, they might say, okay, so is it like a kind of contradicting thing, like real-time in analytics? Usually analytics is something that, we can good enough next day. We have a day of business is closed. Overnight, we do have some ETL job that extracts the data from our operational data source. We'll be doing some of the crunching, the cubings and stuff. And after that, we will print out the report and deliver this report. Stakeholders or shareholders or the people who will be responsible for dealing with the making some critical business decisions. Now, and this is where it brings me to explaining where we're standing today in 2024 in terms of landscape of the analytical applications and analytical workload. So I would like to start with bringing the little bit like a scientific or like a not scientific, but at least approach that visually will show you where different users stand in terms of one against each other. So in the y-axis we have the batch and the real time, and the x-axis we have internal and external. So with the internal external is something that you run inside your organization. You're running this to support business, and you're not necessarily world application. It's not your core business. It's something that supports your business. And the batch and the real time, it's a fairly fairly self-explanatory in terms of how fast and how quickly you're getting this data. This data will be used for certain decisions that you make inside your business. So we'll start with internal and batching. Typical example, reports. What's cool? The Crystal reports. How many of you use Crystal report? Cool. A few people, a few veterans here. No, not now, because I'm trying to remember what was the cool thing at the time. So what was another one? The BERT, it was a part of the Eclipse, also like a reporting system. So different dashboards that they build internal, and those dashboards is not that fancy that we have these days. Those dashboards might be, just show some data that is not changing that often. You might have a dashboard that will be in your office, and it will change, I don't know, every morning. There's some internal things that's also important for a business, like observing how many requests you serving, or how many users you serve, or how many orders you fulfilled, and things like that. Or observe some of the technical details. What's current load average in the system? How many users hitting the system? So something that is important to React, because you might have SREs on call, and they will be making sure that the CPU load average is not be more than something. So this is something that is a real-time-ish, but also internal, because you're using this to support business, but it's not your core business. Now, user-facing analytics. I'm gonna table this for now, because I will be showing the examples of this particular functionality. But in general, this is something that your core business is kind of like either selling this in form of UI or functionality of your application, or maybe API that you're exposing for your customers. And those need to be kind of like a real-time-ish, meaning that reaction time should be less than hours, minutes, seconds, ideally. And some of the reporting features that your system can generate overnight, and you can send to your customers or whatnot. So in terms of like a landscape of software products that can support this. So data warehouses, this is something that's I'm not a data guy. I become the data guy, but before that I was application developer. And in application development world, like a data warehouses is maybe synonym of the monoliths. And when we're talking about our monoliths, we're usually not bragging about this, because we feel a little bit guilty because of this. And some people don't like to talk about data warehouses, but it's still there. Like some of the systems that require have a lot of data in this legacy data warehouse systems. Hadoop was one of the systems that was used to generate these analytical results that was batch and to run some internal workloads. Snowflakes. Some of the systems, more modern systems like a Trino, that allows to do kind of federated of queries across multiple different data sources. BigQuery and the Snowflake, there's modern data warehouse systems that for the modern world. But again, you're not using this data to build the applications, to expose this data to outside world. So for internal and the real-time data, any type of the time series database, Datadog, Grafana, the Prometheus, whatever. Usually, for exposing this information, analytical data, as a feature of your application, you have some sort of either a prepare this data and it cache somewhere, so it will not require real time. So it still will be crunching those numbers overnight, and after that it will be cached in the form of either some key value store that will be exposed to application, or something that you can publish this like in files and PDFs and things like that. So in the last couple of years, we've seen a rise of new cool things. Things around Druid, ClickHouse, Rockset. Those systems allows to build data-driven features in your application using analytical approach. And obviously Pino also is there, and we're going to talk about the real-time analytical systems and how they different and what's the fuss about this. Oh, we have interruption in the word from our sponsor. So we at the Startree, I work at Startree, and we are making the community conference called Real-Time Analytics Summit. And it's going to happen almost in 2 months, or no, less than 2 months. It's going to happen in May in San Jose, California. I will be doing a full day training on Pino, hands-on training, Pino, Flink, and a Kafka I also will have my friend from Confluent, so we will be doing this together, things with Kafka in the Pinot. And also there will be very cool speakers. And if you're interested in this type of jazz, real-time analytics, user-facing analytics, check out this. Since we are friends here, thanks for Tim for inviting me. 35% off on me if you wanna join. Now, so in terms of like, I already mentioned this in the title of this presentation, industry leaders using real-time analytics. But let's talk about why. I mentioned this, the LinkedIn thingy, and a couple years back, the only use of LinkedIn was going there on this resume. There's not much else there. It was cool that, you know, there's like URL and you can put the different certifications, you can put your job experience, but at the end of the day, it was still kind of glorified the resume. And the people on LinkedIn also think about this, like, okay, so how we can use this, how we make our platform more engaging when the people will be actually, you know, and discuss about certain. So they come up with this idea that's called Who Viewed My Review using this type of feature. It's cool, isn't it? Because it's kind of like interesting, like why people look in my profile, what kind of people look in my profile, and like what it's sometimes also filtering when you see when you saw your profile, thinking, wow, that's cool, I'm kind of popular. Now, to build this system, first attempt was to use the search technology. Many of you heard about this. It's called Elasticsearch. Failed miserably because it was not designed to be. It's a great search system. You know, you still can use this for writing the full text search type of capabilities, but it were not designed to solve this particular problem. Specifically, every time when someone clicks on your profile, it's actually, there will be event placed inside the Kafka topic. And before that, it was collected in Elasticsearch, and from the Elasticsearch, they need to run this aggregate to get idea like who was there. Plus, if you start adding different dimensions in terms of geography, where they come from, level of seniority, you want to see if your CEO or CTO looked your profile versus people in the same tier, for example, in the same level of seniority. You want to see dates, so it's another dimension. Those problems can be solved, right? It can be solved with the existing systems because analytical systems, they're designed to be serving multi-dimensional queries. However, it's not very interesting if you will like, okay, who saw my profile a week ago? It's not interesting because you want to know who saw your profile today, couple hours ago. For example, you went to interview, you're expecting that them to call you, and all of a sudden you see, okay, a few people from the company that you just went to interview start looking to your profile, meaning that, okay, I scored this. And this create engagement. That's create the people the desire to stay on this website. So you don't care about who viewed your profile a year ago. Now you need to have this information now, like updated in the real time. So for solving this particular problem, they had to come up with new type of the system. And it was obviously Apache Pinot, and we'll talk about this. Before I'll show you a few other examples. Some of the information on newsfeed. Newsfeed was the next thing that was covered by same data. Or network post update, or some people on your network post the news. Now, you want to have your newsfeed updated in real time because you want to know what's going on there. So this is kind of like the SQL query that will be representing what is happening with your network. So and they start building more and more pieces of functionality based on same data, because data is already there. Kafka captured all these events. Now you need to ingest this into database. Build the queries that, first of all, a high current, to have thousands of people hitting the LinkedIn website, and you want to have many people seeing your profile. You want to have this data fresh. You want to have data the minutes or seconds. And also, it's going to be like very, the many queries is going to happen. Another example that it would be very much to my attempt to create this functionality. Also uses Pinot, and they also build something for restaurant manager. So it is like a different help different restaurants to be customers, and it's their core business because they have a data about the who can deliver. They can get information from the restaurant in terms of like load of this restaurant, how many orders they're serving, and they want to give the ability of seeing this insights for people who use their platform. So they want to have customers to use their system. And this is what we're going to be building in this particular case. So let's break. We have capturing orders that happens in our system. Users go in our website, order. We have a let's say operational data. We have our inventory. In this particular case, our products, different pizzas. So we have ability to enrich the streaming data from that comes from the orders with data that we have in our products. So in this case, we're going to joining this stream to table, and we will have some that will include all possible information, and we want to have to query this data in real time. So when the order comes in, we want to have this data updated. And we're going to be using Apache Pinot for this. And I mentioned that development myself, still like to tinkering with the code, frameworks. I hate SQL, but I'm here. So thing is, you're not exposing the SQL is still. But for me as application developer, that will be powered of this data, but still will have all this like features like a nice UI, nice cool graphs. So these queries needs to go somewhere where I can be, use this to visualize. And in this particular framework or template, anyone before? Like I just plug the Pinot driver, put the SQL and the functionality. Integration also exists. Cool frameworks like a superset. You can like pretty much any system that can talk to SQL. They can talk to JDBC or Python. We have a Go driver, Java, JDBC, and Python driver. So that's how I said this is going to be like a super over-engineered. But think about this. This is kind of like emulates the idea of event-driven system that captures the data. That's yeah. This part will emulate our event-driven real-time functionality where people will clicking around, people ordering things. This will on the MySQL integrate with the operational. Think about this as a modern structure because we're going to be using change data capture. Or in this particular case, I have a service that emulates this load from database. The transform is going to happen on the Kafka Stream side of things. So a join and enrichment. So like for every order, I will only have like a product ID there. And I want to kind of like a flat map or like expand this and have like enriched orders that will be landing in Pinot. So Pinot supports two types of ingestion. I still have to show you how it works. So Pinot works with workloads, real-time workload. So there's ability to do batch loads. There's jobs that allow you to just like feed the data from where like file system, or you can use integration with Kafka and will do a real-time ingestion. Like every time when we will be pushing this event inside the Kafka topic, specifically enriched orders, the Pinot will take these segments into a real-time table, and it will be available to immediately. More importantly, inside the Pinot, we can have the current performance out of the box is not suitable for the serving our queries. We can enable all sorts of indexes that are available in Pinot. And there's like even special type of star tree. This is where the implementation abstraction leaked from the implementation of database into the real world, hence the name of the company, Star Tree. So if you ever done some sort of like an ETL where you need to pre-aggregate some data before query, or you need to do kind of like a pre-cube data, you need to have a play around with different dimensions. So think about the Star Tree index as something that does this automatically based on usage. The more you use the data, the index would be smart enough to rebuild and can build different paths of execution based on different dimensions. So let me quickly show you how it actually works. If you like to play around yourself, again, it's also one Docker Compose file, includes everything. I tried to make this work with one click. There's just like a make command to run this. And this is the QR code that basically gets into this Git repository. And let's see. How does it look like? So let me see. So this is how it works. So this is how it works. And this is the Streamlit UI. All these components was developed with Streamlit. And every data element here backed by particular query that runs against the Pinot. So we have the how many orders we, let me see. If it refreshes, like refresh rate, let's do this more. Yeah, so we can see how many orders would be generated within last minute. It's always nice to see how revenue grows, obviously. We can see how many orders were placed in the last orders and what were the most popular categories. So there's some side orders like fries, maybe vegetarian pizza, even pasta. So, and with this, we can see the most popular items, how many of them are sold, and how many, when the people ordering this, what's the average quantity of those items. So, again, as a disclaimer on the very beginning, this is not the backed by the real data. I had to generate something that would be exciting to show. So that's why I do have the program that generates these orders. So, when I look into my Kafka topic, all my orders will go into this orders topic, and this is how it looks like. Inside order, I have some user who placed this order. I do have the items, and all these items just include product ID. So not super useful unless we will do some sort of enrichment of this data. And there's a different ways how you can do this enrichment. I do have a version of this application that uses the Python framework called ByteWax. I use the version of this application that uses Kafka streams. Anyone like Java people here? Okay, few people. So Kafka Streams, it is the built-in framework built in Apache Kafka. It's a Java library that not allow you, there's no like server, there's no cluster. It's not like a Spark you're running or something like Flink. It's just the code that you write. And in this particular case, my code is implemented using this framework called Quarkus, just for sake of having the things figured out with Docker, the configuration, and all those kind of things. But essentially, the Kafka streams would look something like this. There's two methods. One method will take the every order. For every order, we need to create the like expanded version. So we'll take the orders, we read the inside the order we have the different products, and we're creating another stream. That's what the flat map does. It gets this one stream and creates another stream that will include order ID, product ID, and many other things. Why are we doing this? Because this we're gonna use this as enriched stream. So we will take the product information and join with this stream of data that was like exposed. And the way how it looks like, so remember this is our order placed, bunch of items here. And if I go to my topic as a result called enriched items, each individual item will include information about the product and about particular order. So basically, I'm trying to turn my data into one big table that can be easily query. Like I'm turning the data that comes into my system through operational data store and through the stream. I turn it into the format that would be easy for you to do like any type of analytical stuff. And for this, I do have a connector that listens this Kafka topic enriched items, and the Pinot will suck this data inside the Pinot table. So in this particular case, order items enriched is going to be my orders. So I do have like order quantity, product category, product ID, product image. So as is, but it's in a flat form. So now I can run some sort of queries. And one of the things that's, again, this is information in case I screw up, I have some commands that allows me to, for example, to run this, copy paste. And if I go to my query console, so this is particular, so what it does, so this query will take the most ordered product categories for the last 5 minutes. There's the special type of workflows. So when I run this, so it takes me 5 milliseconds to run over. Let me show you once again. So if we have inside the Kafka topic, how many messages we have? We have roughly 500,000 messages of orders, and those data already dumped in the Pinot. So if I run this with this, this is the result I'm getting from the data. I'll take this order and feed this into one of the dashboards. Once again, let me show you the diagram, like where we were standing. Where's my keynote? So we do have. Oh, nope. Thank you. Data through Kafka land into Kafka topic. We have products from operational data store. We have Kafka streams does the join, and we do enrichment on the Kafka streams. We dump this into Pinot, and after that, we are querying this data using Pinot and Streamlit integration. Any questions about the demo so far? Yes. Say it again? Yeah. Order, we take a collection of product items that was there, and we produce another stream that would be kind of like have a flat structure. After that, we'll take this the product ID information and replace it with the actual product data. So each and every message in the stream will have order information and product information. So when it lands inside a Pinot, we will be able to query this data and run all the sorts of like average. We can run all these counts and all these kind of things that we would be interested in doing. I have another query, for example. So with this, we can do, we can build some sort of the table result where we can get a number of events for the last minute, between 1 minute and 2 minutes, and we get the like average, we get the total, and we can run this query. I'm wondering why it says still total number of docs is not more than. Should zoom. Okay. So we're getting, this is the number of orders per minute. How many events happened within last minute, and like how many like events happened in total events. So we take the price, and we're getting the revenue part that I'm displaying on the dashboard. That's what what the query powers this type of thing. Any other questions? Okay, so and this is also a very cool thing where we're going to talk a little bit about the distributed architecture. So when we're talking about the batch ingestion, let's say we have a file that will include number of this kind of JSON events. It can be just the JSON lines, or it can be array of the things, but essentially it's kind of some event, clickstream, something that happened on the website. And what the Pinot does when we do ingestion, we're ingesting this into table. Table contains things what called segments. Other distributed system might call it partitions. Some system call it shards. It's the unit of storage of this information. An interesting part about the segments is that data stored inside the segments in what we call a columnar structure. So instead of like your OLTP database store everything per row, like we have a one record, we store it as is. Here, we turn it into a columnar form. So instead of having one record that will include this information, we have segments that will include only IP addresses, for example, or only time requests. So we'll take this and kind of sort of like pivoting this. And each segment would be spread across multiple nodes, and each segment will include its own kind of like a piece of data. With this format, it allows the system to run different optimizations. We can apply different, depends on the cardinality of the data. We can apply different, say, strategies to reduce the size, or maybe like figuring out how we can store only one particular thing, so compression and all this kind of stuff. Also, these segments we can spread across multiple servers. And servers, there's actual thing that will be storing the data. So we come up with the name of the server ourselves. No one tells us. So I think it's very inventive, right? The server serves segments. Okay, tough crowd. Okay. Yeah, so the different, now it's going to be cooler because, for example, in Kafka, they call the servers brokers. We also have brokers, but the broker does slightly different things. So broker would be responsible for taking query and will take this query apart, because broker knows where particular segments are stored. So it will send these queries to particular segments. So for example, if we need to data that will be stored in segment 2 and 8, we can run this on server 2 and server 3. And when we get the response, back, and the broker will collect this and send back to our application. We use Zookeeper here to maintain structure and know which like server owns a particular segment. The segments can store inside the server disk, or it can be sent in a deep storage. In this particular case, it also kind of cloud ready because you can actually have this deep store somewhere like in S3. And like when you need to query this old data, your like P99 metric will skew because you need to download this into memory again, and after that serve it from the memory. But it's already kind of like have a concept of like separating storage across the storage. We took this idea in Star Trek Cloud, and we use this concept of the tier storage to optimize how the data, how data will be stored for the longer time. Now, clients talk to brokers because we're sending the query to broker. Broker will be responsible for like scattering this request and after gathering the results from the servers. And we're getting the data can be ingested by servers as well. So when we're creating this, there's no even though Pinot supports SQL, there's no insert type of query. We doing this, the data would be ingested through ingestion jobs. One of the jobs, for example, if we need to do the batching thing, there would be a job that will be constantly reading your, like once read this data source, and after that, data will be available. Or if it's a Kafka example, it will be constantly reading from Kafka. We only give you kind of like a select star type of select from whatever type of queries. You cannot do inserts here. With Kafka though, we support upserts. If the data with the same key will come in, we can update real-time segments. So naming is hard, and the tables that will be populated from the batch ingestion will be called offline tables. I know it's a not super intuitive name because it will sound like this table will not be available for querying, but despite on this name, it's actually available to the query almost immediately. And this is our segments. Every time when we do ingest, we turn this into the thing. With the real-time ingestion, here we were a little bit inventive with the names. It's called a real-time table. And with the real-time table, we will be listening. I don't know if I have this slide because it's a slightly, how many of you are familiar with the concept of consumers inside the Kafka? How when you read, the consumer offset would be stored inside the Kafka. Anyone? Yeah, so forget about this because we're not using this here. So we're using low-level consumer API, and we have a segment per partition inside the Kafka, and we maintain a position of this offset inside the Pinot. Technically, it will be stored inside Zookeeper, but Pinot will be responsible for maintaining. Why we need to do this? Because there will be some jobs that will be responsible for rolling over certain segments, for doing replication and all this kind of stuff. So all these jobs will be taken care of, how the data would be spread across a Pinot cluster. And all this information would be handled by Pinot. There's a concept of minion. It's a special type of jobs that will be running inside a Pinot, and there's this whole framework that will be responsible for dealing with this type of things. So let me show you quickly the configuration for these real-time tables. Every time when I need to create something, it would look something like this. I need to create a table for my orders. I need to create a configuration for the table and the schema to tell Pinot how this data would look like. And inside where's my Pinot, say orders. Here's my schema. This is how my data would look like. ID, user ID, status, and items. I store information about the orders in a JSON. And also we have a JSON index. In the Pinot, you define a JSON path, and you will be able to query inside this JSON thingy. And the tables would look something like this. The most important part here is table configuration. And this is a real-time table. So we support stream type Kafka, we support Pulsar, and we support Kinesis out of the box. And there's a framework that allows you plug virtually any type of real-time system. And this is some configuration that would be specific to this Kafka implementation. We also can do, when we're ingesting, we're not only ingesting this as is, we can do some sort of like a small transformation. So in this particular case, we also can extract the quantity. For example, in this particular total quantity, we can run JSON path type of operations. We inside the quantity, we're also injecting the number. We're looking into order. And after that, we're inserting this as a field, total quantity, and number of products that was ordered in this particular order. For enriched, it's another option. So we do have a schema that will include information about product name, product ID, product category, image, because it's going to be include all this information from Kafka. And again, it's also the Kafka topic, and we do have this functionality here. Does anyone have a question? I have a question. What about joins? Yes, it's a great question. So the reason it's a normal question. Everyone is asking about joins. You're talking about database. Everyone will be asking about joins. So as you can see in this example, I use some external system to do this type of join thing. But the information is there, so I can do this on the Pinot side of things. Before 1.0, Pinot didn't have like a very limited support of joins. And the kind of like the concept was there, so people would use things like a Trino to perform those joins. Now we do introduced special the next version of our query engine to join supported locally, join supported out of the box. So technically, I can do this stuff without having Kafka streams now. So I can ingest my products from my MySQL using either some sort of like application that will use Writer API, or I can have, for example, my data of products ingested inside MySQL in the form of a CSV file. I can use the CSV file to ingest this directly into Pinot, and after that, I can use join. If I want to use joins and stuff inside the Pinot, there is a special check mark, says multi-stage engine, that will allow to perform join out of the box. I have if you're interested in these examples, we do have I think, let me see. I think I make this quick start. It's still private. I'm working to release it, but essentially this is examples where I have a movie information and ratings information. So movie is my offline table, and the ratings is a real-time table. And I'm doing things with join that would look something like this. So in this particular case, I do have movies, but I also do left join of movie ratings based on the movie and rating ID. And after that, I'm populating movie information and rating information using this this type of query. So answer is, you can do pre-join outside and after that, like a store result in Kafka. So I have another example working in Works that will use like a Flink to do the similar thing that Kafka Streams does. But now some of the functionality with joins already supported inside the Pinot. So thank you for this. If you're interested in this, join our Slack community. This is open source Apache Pinot. It's confusing. It's open source Slack from the Apache community. This is Star Tree Slack. If you interested in talking about some Star Tree product, we have a cloud product. We have anomaly detection product that allows you to monitor data streams and build some sort of logic to some of the anomalies called Third Eye. And again, some one of you at the Real-Time Analytics Summit, be organizing this, but there would be people, other companies that would the board, it's pretty cool technology. They kind of like use Kafka with tiered storage and like of Kafka separated the Kafka engine, the Kafka from the storage. So it's a pretty cool event. Again, training day. I'm working really hard to put the very cool content there. My name is, as always, have a nice day. And we still available if you have any questions that you want to ask, like not in front of people. Yeah.
I went to that last year. It's really good.
Thank you. This year? We can.
Would you have to be at a different conference on Saturday?
Because I thought like.
Except my talk.
The talk as well.
What?
Yeah, that's why. That's how I was able to. The only reason why I was able to come, I can do training like whole day, just like okay, sold out. Yeah. People from Stripe, LinkedIn. So the people who run this in yeah, and some people who run the cloud, and there will be some engineers from StarTree will be talking. So yeah, that's gonna be. We will have a cool backpacks. I saw design T-shirts, the hoodies for speakers. Exactly. Yeah. All right. Thank you. Yes. Yes. So yeah, so since we're controlling the ingestion, so we will able to, when we read particular, say we're reading this like CSV file, we figure out, okay, so this is going to be our. We store like the column names, and after that, based on the index of the element inside this row, not the hashed. So it can be hashed. Need to do some sort of like optimization for compression or whatnot. Again, depends on cardinality. Say you have a flight information. Every record will have a flight information. Have a flight date, flight number, the tail number of the plane, duration, and all this kind of. So you will be able to, for example, like flight number would be having some of the, it would be something that very difficult to compress because they are pretty unique. But things around timestamps, things around durations, those things will have a like higher cardinality. So you will be able to do some sort of optimization, create the dictionary that will include like some of the things, and after that just only store dictionary ID instead of actual record. And we pivoted during ingestion. So that's what you are more concerned with the you concerned with the row-based locking thing, any of this. If we need to do update, it usually comes through the upsert. How, I don't know, like log-based trees will be doing compaction. You know, the all data still. There's a bunch of different techniques that's used during ingestion. So we control ingestion, the job that controls ingestion, and that how these segments are formed. So that's why we will be able to, you know, turn around the data. So the query running this, the analytical queries would be much easier and faster on particular column. You don't really care in this query of particular row. You only care about sums, averages, some filtering, and all this kind of stuff. And it would be much easier and more efficient to execute this when it's data stored in columnar form. So you don't need to do any like a post processing with the data. So that's why OLTP system is not very good. You still can do analytical queries on your OLTP system, but you need to mess around with the indexes and all this kind of stuff. So you need to do something with this data, or you run pre-aggregations or something like that, some background process. In this case, you need to maintain this, how often this pre-aggregation would be running, so far and so on. So I don't know, it was more than 30 seconds, I apologize. Which Delta format. Oh, like data lake. So we might support this in the cloud. We might not support this in open source. So yes, but only cloud. You need to check, or maybe there's some open source connector that allows you to ingest this. I know Delta and Iceberg becoming kind of like a very popular format. This is kind of like this Delta you're asking, right? Or you're asking Delta? Yeah. I think support this in a data manager in Starter Cloud. Might not be available in open source, or maybe it's available through third party. I don't believe it supports out of box. I need to check. But this is a very good question. I remember someone asked me, but I don't use this often. I think which is Google. Naming is hard, as always. The input formats. So open source supports CSV, Avro, JSON, Thrift, Parquet, Orc, and Protobuf. I'm pretty sure that Star3 Cloud's Delta Lake connector. Yes, it's a Star3 Cloud. So it's not available in open source. It's it's a cloud thing, but it does support the Delta as a ingest inside the cloud. All right, cool. Class dismissed. Thank you so much for your time. I hope we'll see you online or maybe on the future meetups. It was great. Thanks so much for coming, because today was rainy, 4 presidents in town, and the holiday is coming. That's some dedication. I appreciate this. Thank you so much for sticking around.